faster than the very fabric of spacetime itself. It holds the ability to preserve its awareness of it, and as a result it will gradually disassemble. This notion fills me with a sense of dread. At present our night sky is shifting rapidly, and within the next few decades, or perhaps even sooner, it might become utterly unrecognizable. Astrophysicists are sounding alarms, with experts such as Neil deGrasse Tyson acknowledging the unavoidable impact of the Polaris transformation. The story behind this change is rather surprising. Polaris, known as the North Star, has long been a steady fixture in our sky, serving as an essential reference point for astronomers, navigators, and stargazers alike. However, this may soon be altered, transforming our perception of the heavens and altering how we study the cosmos. Let's take a closer look at the ramifications of this potential shift. For many years, Polaris has acted as a navigational guide for sailors and astronomers, maintaining a stable position in the sky. Its unwavering presence has been crucial for guiding travelers, but this stability may soon be challenged. In September of 2023, a paper from the esteemed Royal Astronomical Society raised questions about the future of this celestial guide. Polaris is nearing an unstable phase, one where it could potentially explode and disappear from view forever, altering the sky as we know it. Before exploring the potential consequences of this event, let's take a deeper dive into the characteristics of the star itself. Polaris stands out because of its closeness to the celestial North Pole. Situated directly above Earth's northern pole, it appears nearly stationary in the sky. It is located within the Ursa Minor constellation, which is also known as the Little Dipper. Polaris shines with a moderate brightness, resembling a yellow-white supergiant star, far larger and brighter than our own Sun. However, Polaris isn't a single entity. It's part of a complicated triple star system comprising Polaris A and Polaris B as a binary pair, while a third star orbits the two. The gravitational forces produced by these stars influence their orbits and behavior, and disturbances in these interactions could cause fluctuations in the star's brightness or pulsation patterns. However, the exact nature of these forces is still not fully understood. Polaris is situated approximately 323 light-years from Earth, meaning that the light we currently see from it began its journey quite some time ago. Therefore, if Polaris were to explode, we wouldn't notice it for over 300 years. In fact, it's even possible that Polaris has already exploded, and we have yet to see the light from that event. Throughout history, the North Star has held immense cultural, navigational, and symbolic importance. Its constant position has made it an indispensable guide for ancient sailors navigating the seas and lands. Symbolically, Polaris has come to represent steadfastness and direction, remaining unchanging in the ever-shifting sky. For astronomers, Polaris has been a vital reference point in the study of stellar movements and variable stars. As a SAID variable star, its periodic changes in brightness have offered key insights into stellar properties and the nature of variable stars. This characteristic has also played a critical role in determining cosmic distances and calibrating scientific instruments. These pulsations follow a predictable rhythm, making the star's behavior easier to forecast. However, recently Polaris has shown signs of deviating from this expected behavior. This irregularity in its pulsation cycle has intrigued astronomers, prompting further investigation into this strange anomaly. Rather than following its usual pattern, Polaris has begun to exhibit erratic dimming, raising concerns that the star may be nearing the end of its life cycle. This is consistent with patterns seen in stars approaching their final stages. The gradual lengthening of Polaris's pulsation period, which was once stable, can be traced to interactions within its star system. There has been a yearly increase of approximately 4.5 seconds in the pulsation period, and while this may seem minor, it carries significant implications. Some astronomers propose that gravitational interactions between the star of the Polaris system could be driving these changes in its atmospheric conditions, directly impacting its pulsation patterns. Others are more concerned that Polaris is approaching a critical stage that could result in an explosion. The similarities between Polaris's behavior and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have demonstrated complex brightness variations, leading to worries that they may be on the verge of a dramatic explosion. Stars in their final stages often show such anomalies before reaching the end of their life cycle. NASA has shown greater concern about Betelgeuse, but formal attention has not yet been fully directed toward Polaris. As a SAID variable star nears the end of its life cycle, it goes through several phases, including the red giant stage and ultimately a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict it has entered the phase of helium exhaustion, which is a typical stage for giant stars nearing their end. These irregularities in Polaris's behavior align with patterns observed in stars at the twilight of their life cycle. However, solid evidence of an impending supernova is still uncertain. Astronomers continue to track these anomalies to better understand the fate of Polaris. Should Polaris undergo a supernova explosion, it would likely be a monumental event in the sky, potentially outshining the moon and remaining visible for days, weeks, or even months. Its brilliance could drastically change our view of key constellations like the Big Dipper or Ursa Major, in which Polaris plays a crucial role. Fortunately, Earth would likely remain safe regardless of whether Polaris explodes, given its size and distance from us. While a Polaris explosion might not be as visually spectacular as Betelgeuse's, it could still be visible to the naked eye for an extended period, outshining nearby stars. Astronomers and observatories would certainly take note, this generating widespread interest both in the academic world and among stargazers. However, the impact on Earth's environment or ecosystems would be less significant compared to a supernova closer to our planet. But what will happen to Polaris itself? What will its fate be after a potential supernova explosion? We must first clarify that while large stars typically end their lives in a supernova explosion, this is not likely to happen with Polaris. When a massive star under a supernova experiences a cataclysmic explosion, marking the final phase in its life, this process involves the complete collapse of the star's core, creating a violent shock wave that causes the star to burst apart. However, Polaris is not massive enough to undergo such a violent explosion. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transition into a white dwarf. This transition will not trigger a supernova, but will instead result in a quieter end as Polaris evolves into a small, incredibly dense stellar remnant. A white dwarf is the compact core of a low to medium mass star that has used up its nuclear fuel. This remnant, although only about the size of Earth, will still be as massive as the Sun. Once this process occurs, we will no longer observe Polaris as we see it today. Comparing the typical effects of a Polaris explosion with actual supernova events provides useful insights into the evolution of stars and their ultimate fates. For example, comparing the expectations with supernova events like SN 1987A and subsequent events such as SN 2011 FA and SN 2014J offers valuable data to understand what might happen to Polaris in the future. For instance, SN 1354 resulted in the formation of the Crab Nebula, a cloud that continues to expand and emit energy across various frequencies, providing astronomers with a rich field of study. Moreover, SN 1987A, observed in the Large Magellanic Cloud, provided crucial insights into nucleosynthesis patterns and the mechanics of supernova remnants such as nebula formation and the release of high-energy radiation. These insights can shed light on the unique characteristics of Polaris. The formation of nebulae like the Crab Nebula results from material released during a supernova explosion interacting with surrounding interstellar gas and dust. This enriches the gas and dust with heavy elements and contributes to the continuous cycle of starbirth and death. Additionally, the release of high-energy particles and vast beams propelled by supernova shock waves has significant implications for astrophysical processes and cosmic radiation. To make a definitive comparison, scientists are studying differences in the production and speed of ejected materials between Polaris's potential explosion and other observed supernova events. By examining light curves, spectra, and remnants from these events, they can extrapolate similar characteristics for Polaris's anticipated explosion. This research will help determine if Polaris's explosion could result in nebula formation or notable stellar distributions. Another critical area of study is the pulsational variability of stars nearing the end of their life stages. By comparing Polaris with other supernova progenitors, astronomers hope to gain a better understanding of the mechanisms behind stellar explosions. Pulsational variation and stars approaching their death may signal internal instability or an impending catastrophic event, offering important clues about the processes leading to supernova explosions. Despite detailed observations and research, space experts are still puzzled by the anomalies in Polaris's behavior. Understanding the forces causing these irregularities is key to advancing our knowledge of stellar evolution. The investigation into the factors behind Polaris's erratic pulsations requires cooperation across multiple scientific disciplines and the development of advanced models and observational techniques. The potential loss of Polaris as a celestial reference point raises fundamental questions for astronomical research. Ground-based telescopes and measurements of celestial distances would need to be recalibrated, affecting the accuracy of cosmic assessments. The disappearance of Polaris would also disrupt navigation systems and cultural practices that rely on celestial markers. Underscoring the significance of this event, the mysterious behavior of Polaris highlights the necessity for deeper studies and focused research. Astronomers must address the complexities surrounding its irregular pulsations and offer meaningful responses to determine the star's future.